The New Jersey Pine Barrens is a unique ecosystem with a tremendous biodiversity. All of the native species have adapted to the geology, topography, hydrology, and climate unique to the 1.4 million acre region. It is home to a vast amount of microorganisms, animals, plants, and fungi. In this video, I am going to talk about a specific type of fungi known as a lichen. I will go over what a lichen is, uses of lichens, the different types of lichens, lichen terminology, and chemical tests used to identify lichens. As you may or may not have already seen, I've passed out some samples of lichens that I found throughout various locations in the Pine Barrens. And as you may notice, each of them are already classified for you. You're welcome. Now, let's move into the first topic. Kingdom fungi consist of 77,000 species, all taxonomically placed into 4 phylums: Ascomycota, Basidiomycota, Zygomycota, and Deuteromycota. However, there was once a 5th phylum known as Mycophycophyta. This phylum was used to classify lichens until taxonomists decided to classify each lichen based on the phylum of the fungal species involved with the symbiotic relationship.
Wait, did you say symbiotic relationship?
Ah, Connor, I'm glad you could join me. And yes, symbiotic relationship. Lichens are not one, but 2 organisms that work together in a mutualistic relationship to make what is known as a dual organism. Every lichen that you will ever find is consisted of a fungus and green algae, as in the plant from phylum Chlorophyta. No, as in the photosynthetic bacteria known as cyanobacteria, which are commonly and incorrectly referred to as green algae. Unlike the eukaryotic green algae, cyanobacteria is a prokaryotic organism, but like the green algae, it can also conduct photosynthesis to produce food, which makes it a suitable companion for the non-photosynthetic conducting fungus, which in return breaks down the sugars made from the cyanobacteria, which helps feed both organisms, supplies water and minerals, and gives it a home. Alone, each of them struggle for survival on this planet, but together, they can live in even the most uninhabitable of places. Not that the Pine Barrens is an uninhabitable place, but not just any species can waltz on in and expect to reproduce and live comfortably here. Okay, maybe except those, and that, and okay, point being, lichens are an underestimated species that have been successful throughout its time on this planet, and deserve a little more recognition.
Okay, so it's great that lichens can survive so well in the world, but what do they even do?
Well, Connor, since lichens are photosynthetic, they help produce the very oxygen you and I are breathing right now, making them just as important as any other photosynthetic species. Lichens are a great indicator species for the presence of sulfur dioxide, as they will not grow and survive in areas heavily polluted with the gas. Crusty lichens have a better tolerance to this pollution, whereas shrubby and leafy lichens do not. Sulfur dioxide destroys the chlorophyll of the cyanobacteria when accumulated rapidly, thus inhibiting photosynthesis and killing the lichen. Sulfur dioxide, when combined with rainwater, makes sulfuric acid and sulfurous acid, which by the sounds of their names are acids. These acids can harm lichens, as well as other plants depending on their strengths, which is why in heavily polluted areas you will not see lichen colonization. Certain lichens can be used to make dyes by letting them simmer in water or soaking them in ammonia water with the desired material. It is a lengthy process, but the outcome is worth it. Lichens are also food for insects, caribou, mountain sheep, and goats.
You mentioned before that crusty lichens have a better tolerance to sulfur dioxide pollution, unlike shrubby and leafy lichens. What exactly do you mean when you say crusty, shrubby, and leafy?
So, lichens come in various appearances, which are used to help identify them. There are 3 basic types to know. Crustose lichens are ones that look crusty in appearance. The most common crustose lichen in the Pine Barrens is tar lichen. Your shrubby lichens are considered to be fruticose and include the genus Cladonia. Most of the species I handed out at the start of this are from this genus. The leafy lichens are foliose, which are mostly genus Parmelia, which are shield lichens, and Physicia. There is a 4th type called squamulose, or lobed, that is considered to be the intermediate between crustose and foliose. They are known for their squamules. What? Don't worry, that will be explained in the next section. Just like how there are different names for each part of our bodies, There are different names for the body parts of a lichen. These body parts are used to help identify the lichen, and not every lichen has every body part. Don't worry, there's not a quiz on this. The first term you should know is thallus. This is the plant body of a lichen dominated by the fungus which gives the shape due to their hyphae. It is also a term that will be used as reference for pretty much every other part of a lichen, so if there is one to know this one. There are 4 layers of the thallus. The upper cortex, which is a dense layer of fungal tissue found on pretty much all lichens. Below that is a photosynthetic layer made out of cyanobacteria. Then there is the medulla, which is made of loose hyphae which create air spaces for water storage. The last layer is the lower cortex, which resembles the upper cortex but also has rhizines. Rhizines are the root-like structures underneath the thallus that act as anchors for the lichen. Squamules are scale-like appendages of the thallus. Apothecia are cup-shaped fruiting bodies found on the thallus which contain fungal spores. Podacia are upright thallus which can be tipped with apothecia. Isidia are cylindrical outgrowths from the thallus which aids in asexual reproduction. Serratia are microscopic asexual reproductive cells that look like a powder on the thallus. Chemical testing is done by mycologists to help identify lichens through a color reaction. The common chemicals used for testing are potassium hydroxide, calcium hypochlorite found in bleach, iodine from Lugol's solution, paraphenylene diamine, and any weak acid, such as lemon juice. I decided to try out the K test, the C test, the KC test, and the I test of certain lichens. The KC test is a combination of the K test and the C test, where bleach is followed up after a drop of potassium hydroxide. For the K test, I used a 15% solution of potassium hydroxide. For the C test, I used Clorox bleach, which contained sodium hypochlorite, as I could not find any calcium hypochlorite. Since calcium hypochlorite was not used, the results for my C test did vary and would not be considered to be accurate. However, I still insisted on trying it out anyway. For the I test, I used iodine potassium iodide. To save time, all the tests I did were only on the thallus of each lichen. A positive result would show a color change, whereas a negative result would not show any color change. To save you the agony of an hour of getting negative results, I will show you a few negative results and a few positive results I observed during the test. Well, this is the end of my presentation where I show you all of my sources so I don't get in trouble for any plagiarism. I personally learned a lot more about lichens by doing this project, and I hope I was able to teach you a little more about them as well. Even today, I'm still trying to identify most lichens that I come across and collect. It is not an easy job, as many lichens look alike at first glance. I mean, just look at all of these British soldier lichens. You wouldn't believe me if I said they all were different species due to the minor details. Although they may be sometimes confused as moss or just some weird looking plant, they're their own dual organisms that were able to find their way into the pine barrens and make it the unique ecosystem that it still is today. Thank you, Connor, for joining me.
My pleasure.
And thank you for watching. That hopefully looked really cool.